Welcome to Malabar College online class part 2 Fourier integrals. Today I am discussing how to find using Fourier integral representation. We have to show that integral 0 to infinity sin omega minus omega cos omega by omega square sin x omega d omega equal to pi by 2x if 0 less than x less than 1 equal to pi by 4 if x equal to 1 equal to 0 if x greater than 1. This is a university question in the previous years. So in this case there are not given what is f of x. So we have to take an f of x here. So let I am taking f of x equal to here pi by 2x is the answer here. So we have to take pi by 2x here in between 0 and 1 and don't take pi by 4 here. It is a substituted value. So we take next 0 equal to 0 if x greater than 1. So this is our f of x. And in the question we have sin x omega. So we take Fourier sine integral of f of x. So we write the formula. The Fourier sine integral of f of x is f of x equal to integral 0 to infinity b omega sin x omega d omega, where b omega equal to 2 by pi integral 0 to infinity f of v sin omega v dv. This is discussed in the earlier classes, the formula. So we have this equal to 2 by pi integral 0 to infinity. In place of integral 0 to infinity we have the limit here 0 to 1. So we substitute here 0 to 1, and in place of f of v we are given f of x equal to we have taken f of x equal to pi by 2x. So we replace x by v, so which is pi by 2v, then sin omega v dv. Then we take, when we cancel pi and 2, so we will get the remaining is integral 0 to 1 v sin omega v dv. So we have to integrate v sin omega v dv. So for that we know what is integral of uv. Integral of uv is first function into integral of second minus derivative of first into integral of second plus etc. So first function is v, second function is sin omega v. So while integrating first function into v into first function is v here into integral of sin is minus cos. So minus cos omega v is here, so omega v, and together with v we have omega here, so divided by omega minus derivative of v with respect to v. Derivative of v with respect to v is 1. So derivative of v is 1. Next we have to integrate this function which is given inside the bracket. So the minus is there, minus you write as it is minus. Integral of cos is sine. So sin omega v divided by then there is an omega here, the previous omega is there, and while integrating we will get again an omega, so omega into omega is omega square will come here. So you remember that while omega v is integrating, first we will get divided by omega, second we will get divided by omega square, third we will get divided by omega cube, etc. Like that we will get, and we have to apply the limit from 0 to 1. So in place of v we have to substitute, I take the first term here, this is the first term, so I am substituting here 1 here. So 1, if I am substituting, I will get 1 into minus cos omega into 1, which is minus cos omega by omega. This is minus cos omega by omega. Then minus upper limit minus. So upper limit minus means minus of minus is there here. Minus of minus, which is plus here. I have written here plus, but the value is 0 here. So v, if you are substituting v is 0, 0 multiplied by any value is 0. So this I am writing here 0. So the first term is over. This complete term is over. Now I am making this minus of minus is positive here. So minus of minus we will get positive here. So this is plus here. So this I am writing plus here. The upper limit for the next term I have to apply, the upper limit is 1 here. So sin omega into 1, which is sin omega by omega square. So by omega square. Then minus lower limit is 0 here, so sin 0 is 0, so no need to write 0 here. So we have two terms here. One is minus cos omega by omega square, omega. The second one is plus sin omega by omega square. So while writing the next step, I am writing the positive term first, sin omega here, sin omega, minus, and if you multiply by an omega here, omega down and omega up, I will get omega cos omega, so that the denominator is omega square. Here if I am multiplying by omega by omega, omega cos omega by omega square will come. So omega cos omega by omega square. So this is the second term I am writing here. So this is our b omega. This is our omega. Substituting this value here in place of b omega, we will get like this. So we will get the answer like this: f of x equal to integral 0 to infinity sin omega minus omega cos omega by omega square sin x omega d omega. So this I am writing here, and again equal to f of x it is. If equal to f of x it is, and in between f of x it is the value. What is the value of f of x here? It is pi by 2x. So in between 0 and 1 it is pi by 2x. But when x equal to 0, what will happen? When x equal to 1, the one value is 0 here, one value is 1 here. So at x equal to 1, what will happen? X equal to 1, here x equal to 1, if I am substituting, pi by 2 into 1 will come. Pi by 2 into 1. This is the end value here. The end value, if you are starting here, from here, the value is 0 here. So pi by 2 into 1 means here the value is pi by 2 and here the value is 0. Which means at the point 1 here we will get pi by 2. Pi by 2 into 1 means pi by 2. At the point 1 here we will get 0 here. So these two values are different. Means there is a point of discontinuity here. At x equal to 1 we have a point of discontinuity. Why? Here pi by 2 into 1, pi by 2 will come. Here 0 will come. So these two values are different. The different values means there is a point of discontinuity at x equal to 1. In place of discontinuity at x equal to 1, what we have to write? We have to take the average of these two values. One is pi by 2 and one is 0 divided by 2. So pi by 2 plus 0 by 2, which is pi by 4 here. So at x equal to 1 the value will come pi by 4, and when x equal to 0, pi by 2 into 0 is 0 here. So there are three values: pi by 2x in between 0 and 1, pi by 4 at x equal to 1 equal to 0, x greater than 1. Next we have to find out the Fourier. Find the Fourier cosine transform of f of x equal to x square in between 0 and 1 equal to 0, x greater than 1. So we write Fourier cosine transform of formula here. The direct question it is. So we write the Fourier cosine transform of f of x is f of x equal to root 2 by pi integral 0 to infinity fc omega cos omega x d omega, where fc omega equal to root 2 by pi integral 0 to infinity f of x cos omega x dx. And these two are the formula we already have discussed earlier. In this f of x we have to substitute, which is x square in between 0 and 1. So I am substituting f in place of f of x square here. Then cos omega x is as it is. Then we have to integrate these two functions. We have two functions here. We have to apply the formula of integral uv. U is x square here, v is cos omega x here. So root 2 by pi is taken out and I am integrating the function here. So first function is x square into integral of cos omega x is sin omega x by omega, as we discussed earlier. So we will get the first function into integral of second minus derivative of x square is 2x. Derivative of x square is 2x. Integral of sin is minus cos. So minus cos omega x and divided by w is here. W, if you are integrating again, w square will come. Next cube will come, etc. As I told you in the previous question. So this one is minus cos omega x by omega square. This is the second integral will come. Then minus, then alternate plus. Then derivative of 2x is 2. So I am writing here 2. And a minus is here, write minus here. Integral of cos is sin here. So cos omega x, if you are integrating, will get sin omega x by omega square will become omega cube. It will increase 1 by 1. Then and here next the derivative of 2 is 0 here. So we have to stop here our integral. So the limit is 0 to 1 we have to apply, which is equal to integral root 2 by pi. Then we apply the upper limit and lower limit. If you are applying the upper limit 1 here, it will come 1 here, so 1 sin omega into 1 sin omega by omega, minus lower limit is 0 here, 0 in multiplied by n number is 0 here, plus 2 into 1 which is 2, and this minus of minus I have made positive here first, so this is plus here, 2 into 1 2, then cos omega into 1 which is cos omega by omega square. Next I have to apply 0 here, 2 into 0 it is 0. Next it will come sin 2 into upper limit is this minus I am taking here, minus out, then 2 into sin omega into 1 which is 2 into sin omega by omega cube, 0 if I am substituting sin 0 is 0 here. So this term I am writing root 2 by pi, this is writing as it is sin omega by omega, 2 cos omega by omega square minus 2 sin omega by omega cube. This is what about f of x. So in place of f of x I have to substitute fc omega here. This fc omega we obtained this much I have to substitute here, and we know root 2 by pi into root 2 pi pi which is 2 by pi into these terms will come here, and cos omega x d omega, that is there in here, cos omega x d omega. This is what about the second question. I will continue the class in the third part. Okay, thank you for watching.